Hi all, this is my third video from section 10.2 and the question is what happens, not just what if we don't meet criteria, what if we don't meet this criteria? What if NPQ is not greater than or equal to 10 and is in fact less than 10? Now this doesn't happen very often, but because we've got skills, it doesn't mean we're dead in the water. What we do still have, as long as n is 5% of the population, less than 5% of the population, we still have a binomial distribution. So let's run through this example here. What if we want to test a claim that a coin favors heads, and our data shows that we get 7 heads out of 8 tosses, which does look really promising, I have to say. So we're going to do a hypothesis test on this. So we're going to go through all of the steps. The first thing we're going to do is we're going to write the claim in math. So here's our claim. Oh, please notice there is no mention of means or proportions in here anywhere. Yes, we're in section 10.2, which is all about proportions, but I still want you to be able to tell what is our parameter here. So what's the data we collected? The data we collected was heads or tails. Remember, we collect one data value from each trial, so 7 heads isn't going to be the data because that's from 7 different trials. From each individual trial, from each coin flip, it was either a heads or a tails. That's qualitative data. That makes this a question about proportions. So here's our claim that the proportion, well, if we're saying it favors heads, it means it's not 50-50 anymore. It means it's greater than 50. Complement, the proportion is less than or equal to 50%. Null hypothesis is always, always, always equality. And the alternative is either going to be the claim or the complement. Whichever one of these two does not have equality in it. So that's this one here. So we have another example of where the alternative hypothesis is the same as the claim. Okie dokie, so we've got that. That was step 2. Step 3 is collect data. We have n being 8 and the number that meet criteria being heads is 7. So that's our data, and we've got that already. And it does say in the problem that our significance level is going to be 0.05. So what's our p-value? So that I can compare it to the significance level. Well, before I reach to my calculator, I'm going to do my criteria check. Is my data SRS? I'm going to go for yes because coin flips are all independent from each other. That's a bit tricky. Take my word for it. Then I'm going to have, are my coin flips, is 8 less than 5% of the population of all coin flips on this coin? There's an infinite number of possible coin flips on this coin, whether they're flipped or not. So not a problem there. So lastly, my NPQ, is that greater than or equal to 10? And here's what I've got. N is 8, P is 0.5, Q is 0.5. So in other words, what's 8 times 0.25, which I can actually tell you without reaching for my calculator, is 2. I did not meet criteria. But because I have independence here, I get to still say my distribution is binomial. But instead of reaching for my calculator, I'm going to have to think about this puppy. So now my p-value, I have to go back to what's the definition of a p-value. The probability of getting the observed data, the probability of x being 7 or actually more, given that the true proportion of coin flips is 50%, because we're assuming that the null hypothesis is true. Why was it greater than? Because it's a left-tailed test. Remember, my alternative hypothesis points in the direction of which tail I'm looking at. Here's my picture. Binomial distributions can be approximated normally, so it kind of looks like that. Here's my mean. I have to figure out what my mean is, but 7 is up here. And because I'm looking at the left tail, I'm looking at the probability of getting 7, and I'm looking at the probability of getting 8, because this is my left tail. Okie dokie, what is my mean, by the way? My mean is NP, because it's binomial. So N was 8, and P was 0.5 equals 4. So here's my mean right here. And because it's left-tailed, I don't have to worry about values equidistant to the other side. That was for a two-tailed test. So I'm just wondering, what is this probability? I'm going to have to erase some of the screen here because I am completely out of space. Give me a second. Oh, I forgot to pause the video, so you got to watch me erase. Sorry about that. Anyway, I forgot what I was doing. Oh yeah, I was finding my p-value. So my p-value in this particular problem is the probability that x is greater than or equal to 7 on a binomial distribution. And that's relatively easy. It's a bit of a challenge because it's greater than or equal to 7. If it were less than or equal to, we would jump right there. But because it's greater than or equal to, I'm going to need 1 minus binom CDF. And that our n is going to be 8, number of coin flips. P is going to be 0.5, because we're assuming that the true proportion is 0.5. The true probability is 0.5. And now it's actually going to be 6, because what I want to subtract off is all the values not including 7. So we'll start with 6. And so I have to reach for my calculator, because I don't actually believe I have this answer. Give me a second. I will pause this time. Okay, so I just put all of this into my calculator, exactly as it says here. What we've got here, 1 minus binom CDF, n is 8, p is 0.5, and 6 is the number that I want to the highest of the values that I want to subtract off. And here's what my calculator gave me, 0.035, and I'm going to round to 4 decimal places because I can't help myself. So that's my p-value, and my p-value is less than our significance value being 0.05. We got that up here. And so the p is high. Null will fly. So therefore we reject the alternative, which was the claim. Oh, gotta pause here. Not actually pause, but I have to do a whole buttload of scribbling here, don't I? That is so not true. You know, some part of my brain was like going, really? I would have said that 7 out of 8 being heads did favor heads. And here's my problem. 0.035 right here, that is less than. So I'm not talking about the p being high. Jeez, maybe this should be my last video of the night. I'm kind of tired here. The p is low. P is low. I went off script there, didn't I? Null must go. So instead we embrace the alternative, which was the claim, and we're in favor of the claim, and I'm going to say so as soon as I have enough space to write down all of the claim there. I'm not going to even pause. I'm just going to erase like a mad woman here. good enough for me. So here is our claim. The evidence supports the claim that this coin favors heads. As conclusions go, that one wasn't so bad. Okie dokie, I am going to pause here because I don't think I can be coherent anymore, and that's not helpful for video making. So thanks for watching, and I'll see if I can get up any more by the end of the quarter.